All right, everybody. Thanks for joining. Here we go. Excellent. Okay, Shane, I think we are live. Over to you.
Perfect. Thanks, Stefano. Hello, everyone. Thank you for joining DBA Fundamentals user group. Today, pleasure to bring Azure MLOps, bring your DevOps to machine learning. Very thankful to Stefano to bring this talk to us. If you can see my screen, you'll see in the top right-hand side, you've got myself, you've got Steve Cantrell and Kevin Wilkie, as well as our social media handles if you want to get in touch with us. Apart from that, the list on the right-hand side, we have a couple of ways you can get in touch with us, including our website, dbafund.com. This video will be recorded up on YouTube and dbafundtube.com within the next week or so, as well as information how to get to X, DBA Fund, and SQL Slack as well. Just a couple of home things to bring up before we get on to the actual presentation. A couple of the conferences coming up. We've got SQL Saturday Jacksonville, Florida, coming up on May the 4th. I've never been, but I've heard it's actually an epic conference. And we have Data Grilling coming up on May the 16th to the 17th, which I have been to and highly recommend. Remember that this presentation is recorded, so if you don't want to appear on the recording, turn off your video. Please mute yourself, and if you have any questions, please type them in the chat. I'll be monitoring that throughout the presentation. And apart from that, I shall leave it up to you, Stefano. All yours.
Okay, thanks for the introduction. And again, welcome everybody to this session. Long introduction there, but I'll introduce myself very briefly. I've been working on machine learning and AI technologies for many years now. I used to be at Microsoft as well in the Azure product group, specifically looking after confidential computing, so all the aspect of security, security protection of data, and it was massive impact. This technology has a massive impact on protection of data in machine learning context. I do other things now, and I'm also a lecturer for training courses for a university. I'm based in Australia, and yes, one of the AI in general has been a big passion of mine, and I use the Azure platform as a reference, as a technology platform for most of my experiments. And when I say experiments, I'm using the data scientist terminology for what is a project that is built using a combination of data, models, and algorithm. Now, all this together is what represents a typical AI-driven project, and has several components on it, which we'll see in a moment. And all these components obviously need to be glued together to make sense at the end. And as a normal software application, you will build a bit of a front end, a back end, data model, everything that builds the application itself, the full stack. The same is for a machine learning application, an AI application in general. And the reason I'm saying this is that often for whoever works in this space, there is a sort of a siloed separation between what the data scientists do, which is produce the algorithm and train the models and engineer the data to be fit for the model itself, and what the other side, so the normal software engineers do, which is maybe your React front end, some APIs on the back end, and then they consume the AI services. Microsoft in some way has spoiled us, right, by publishing the AI services as REST APIs. Those that we used to call cognitive services, now AI services, which is fantastic because they also add the capabilities of open AI, so all the generative AI capabilities, just simply exposed as a REST API. But if you think about it for a moment, yes, it's a REST API, so any developer in any programming language that can do an HTTP call can consume these services. But if you think for a moment, the work that is behind is all the preparation of the model to be trained, looking into historical data with thousands and thousands, probably even millions of text, images, any objects that have been used for train the model for that specific service, whether it is text analysis, sentiment analysis, translation, speech recognition, voice synthesis, object detection, computer vision, all of them, all these AI services are as simple as a REST API, and that can be consumed, as said, in any programming language that can do an HTTP call to an endpoint. Now, these two silos at some point have to work together. We cannot keep on working with the data scientist team that produce these models and expose the API and the traditional web or desktop applications built by a separate teams that at the end consume these endpoints, these AI endpoints, without even knowing what there is behind. And it is true, we don't need to know how things work behind the hood, but there is some value in understanding how we can leverage these AI services better at scale with proper performance in place. And I'm going to show you in a moment why the problem exists and what Microsoft has done in the Azure platform to rectify this gap that we used to have this complete separation of the two aspects of the software development lifecycle. All right, so first of all, feel free to ask questions anytime. Type in the chat if it's convenient for you. I have the chat here in Teams open in front of me, so I can have a look any moment, or just unmute yourself and ask question in voice. Don't wait until the end, because there are several topics and you may forget the question or just go out of context. 1 second. All right. Okay. Where do I share my screen? Here we go. Sharing the screen, I think is coming up. Okay, what you're seeing now is the Azure portal. We are not there yet. First, just a couple of slides to introduce the topic, give you a bit of context, and align up on terminology as well. And then we get started with some demonstration of what the problem is and how to address it, right? Okay. Now, you probably have seen this diagram already, but very briefly, let's define MLOps. And everybody is probably familiar already with the traditional DevOps. We are just adding the machine learning component to the DevOps. Maybe writing ML DevOps or DevOps DevMLOps was a bit too long and difficult to pronounce. But MLOps, we're not forgetting the devs. They're still there. We're just putting everything together. Remember, the two silos are ML, so the data science on one side, and the traditional software engineering, the software development life cycle as we know it, right? They are now going to work together. So ML and Dev and Ops. As said, probably saying ML DevOps was to be too long. We just say MLOps. Now, experiment. Experiments is a big component of the machine learning life cycle. Don't get confused. Sometimes people are on the terminology. Experiment in normal English language is something that we try, we give it a try and see how it goes. Yeah, sort of in data science, but there is a bit more in that. What an experiment is in data science is what is the equivalent of a project in software development, in software engineering, more traditional way. It's really the entire life cycle. Let's start a new project. Scientists call it, let's start a new experiment, okay? Which it doesn't mean that we are going to try things, we're actually doing it for real, for good, with all the aspect of acquire the data, build the algorithm, and expose this algorithm and the data itself as a service to be consumed then by the other silo, but we don't want the other silo to be isolated anymore. So we're going to put them everything together. The dev, that's the traditional part of it, still remain there. We'll consume the machine learning service as an API, integrate, so all the aspect of automation remains as is. Automation of testing, automation of deployment of the infrastructure, code and infrastructure, and obviously all the good qualities of the operations, monitoring, business continuity, and everything else keeps on staying as is. We're just putting everything together. So basically, we are combining all the good things that the two silos, again, keep on using this term, the two departments, the data scientists and the software engineering use together. And this is what MLOps brings as a benefit. The ability to have a single pipeline where code and data is actually goes along hand in hand from the very beginning to the end. Pipelines that are obviously automatic. The important thing, they can be validated. So also, not only we can verify data, we can verify, oh gosh, the code, the algorithm with unit test, integration test, system test, whatever we do for validation, for acceptance of a functionality of an application. But we do the same automation of testing also on the data itself, because there is no machine learning without data. That cannot be, right? So that is the very, very important aspect of MLOps that we are adding, we are introducing all the automation that we already know and we already do to code, also to data, and putting everything together. Now, this diagram, there is a lot of information in here, so I'm not going to dive into each box in detail, but just to give you a very high level visibility on what this is all about, is trying to depict the application lifecycle, starting from, hey, let's start this project, and we have an understanding of the business requirements, hopefully. And then we start building our model, which is a combination of acquiring data from different data sources, feature engineering, which is the manipulation of the data itself to fit for the specific purpose. Now, sometimes when we acquire data from different sources, there may be gaps, there may be missing data points. So feature engineering is about producing or filling the gaps in the data that we have in input. Then obviously all the training and the evaluation of the model before the model is deployed and is made available for consumption from the application side of it, which will be used for scoring, for the prediction part of it. And again, if there is any confusion on terminology, just let me know. It is absolutely okay to ask any kind of questions. Scoring or prediction is consuming the endpoint or the machine learning endpoint to obtain a value out of it. So basically, after we train these models and all these models acquire all the information on the data, then we use we expose this service as a likely a REST API. It's very common to do that now. And then the application will make a call to this API. Very likely it's a protected API with some input parameters, which will then generate a response, which we call a prediction, and a score, which indicates the likelihood that the prediction is correct or not. And keep this in mind, machine learning and any AI technology is always based on a score, which is an indication of how close or how reliable is that prediction itself. And typically that score is expressed as a value between 0 and 1, where 0 is I didn't get it at all, I have no idea what it is, or 1 obviously is 100%, which is never going to happen. It's always going to be 0.99999 with a lot of nines to get as close as possible to 1, but is an indication of a probability, right? So the likelihood that an apple is being recognized as an apple, an orange as an orange, or text in different languages, and so on. So whatever services you're doing. All right, okay. Now, this is sort of a very high level, I said, the life cycle from a data deployment perspective. Let's have a look at what is the pain point that we have at the moment with the technology that exists in the Azure portal, but in general in the space of building machine learning and AI application together with a development team. Now, I'm in the Azure portal. I will just zoom in a little bit. It's already 150, 170. It should be good enough to see, hopefully. I want to point you to a couple of services. There are many services in Azure for AI. Probably you have already seen some of these. If we go to the Azure Marketplace, we go into the AI and machine learning section or category. Then we can see that there are different AI services: speech, language, computer vision, translator, and so on, right? So these are the cognitive services or AI services. And if we have a look into the full list, we can also see the latest addition in a moment, as soon as it opens. And this addition includes also the Azure OpenAI service, which is a result of the collaboration that Microsoft is doing with OpenAI. So ChatGPT, DALL-E for image generation, Whisper for voice, and all these nice services. Now, said that, this is just a diversion from what I meant to say. Let's focus on our content for today, which is the existing services, any computer vision, bot services, face APIs, language, all of them are all pre-built, pre-trained models. And when I say this, it means that if I go into computer vision, for example, now I have a few computer vision service already created here in my subscription. Have a look into this. I see this section keys and endpoint. This is the information that I need to connect to this API. These are the keys that are used to access this service API. It's a REST API, so there is a JSON payload in input. Typically, is a post. It's a REST API, but it's only post, to be honest. A few of them have also GET, but there is no patch, there is no delete. So it's mostly posting a payload to this endpoint, authorizing with the key in the HTTP header, and then obtaining a JSON back in response, right? Now, in doing this, these services are specialized. This one is computer vision, so you can use it for object detection, description of an image, and there are other ones that are all specialized in whatever they do: speech synthesis, translation, text analysis, etc., etc. Now, how does this service work? Well, how does this service know that if I take, I don't know, if I take an apple, an orange, okay, let's stay in the silly and simple examples of fruit. That is an apple, that is an orange. So how does the computer vision, which does object detection, as I mentioned, recognize that particular object? Well, we need to say a big thank you to Microsoft for collecting a lot of apples, a lot of oranges, a lot of bananas around the world, and capturing their images. Millions of apples, millions of oranges, millions of bananas, all, and build, instruct, train the model with all these images. So the engineers at Microsoft have been tagging all these images, which is basically they take an image of the orange, say this is an orange, another one, orange, 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 apple, and so on, so on, so on. So they keep on going for thousands, hundreds of thousands, likely even millions of different images. So they instruct the model on how to differentiate one fruit from another one object from another one, and so on. And they've done this for many type of different objects, to a point that this computer vision service is very accurate. It can do a very good recognition of object, description of image, and a lot of other things. The same for text, recognition of a language over the other one. Now it's very hard that some AI service will not be able to understand and recognize a language. Translation has become incredibly accurate. If you try to use these other service, not computer vision, but the speech service. No, sorry, the speech. Yes, the speech service. If you try to use the speech service, it's exactly the same. So we go to key and endpoint. We have the key to authenticate the service and the endpoint to use for connecting to this API. Then in the JSON payload, you pass some text, for example, and then you obtain a synthesis of the voice, and you can choose the different voice. There are different voices that are all neural voices, male and female, different accent. There is American accent, a British accent, Australian accent, and a lot of other languages. I think over 120 different languages supported. So huge. And there is also the other way around, you know? So you can pass a voice, so you can capture a voice, a speech with the mic, or you can upload a file, serialize in JSON as a base64, pass it to the endpoint, and obtain the transcription of that voice into text. So speech recognition and voice synthesis, right? And it is incredibly accurate. You should definitely try. No, give a try. It is called speech service. It's just fantastic. And said because it's a REST endpoint, you can use any programming language. You can do it in Python, Java, C#, Rust, Go, Golang, whatever programming language can do an HTTP call. It's so accurate that I use a lot this service. Even when I speak in English with my accent, it's perfect. It's unbelievable. You recognize everything that I'm saying. And I'm even surprised. Sometimes people in front of me don't understand me. And then this AI service gets everything. Unbelievable. And it's not been trained on my voice, right? So it's not like when you set up a new phone or I don't know, I don't want to say brands here now because we are recording the session, but you know, the like of Siri, Alexa, I said that you know, it asks you to say this message, say this sentence, because then it sort of gets used to the pitch of your voice, these sorts of things. It's not like that. It's not being trained on my voice or my accent or anybody else, right? They are all pre-built services and they just work perfectly. I'm telling you. I mean, I'm not here to sell you any of these services, but I just love how accurate they are. Now, again, this has been pre-trained on a lot of different voices, accent. They use neural network voices for the generation of synthesized voice. So the service is great, but there is a big challenge that all these services have. And this challenge is that all these AI services are built, work on predefined models that have been trained by Microsoft engineers. And this is the power of it, this is the strength of the services, but there's also their weakness. Because the moment you introduce something that is a little bit unclear, no, for example, an object that is not clear whether it's one type or the other one, then you get a score, you get an approximation, but that approximation is never going to give you a certainty, obviously, because it is approximation, right? So how do you classify one thing over the other one? I'll show you a quick example, right? I want to show you one thing that I'm trying to get in the screen and is a little bit slow, but give me a second. I'm getting there. I tried an experiment a little bit ago with this. I have some pictures here that I use as a model, as a tester for to try the different algorithm, right? So I have some flowers here, and obviously these are obviously flowers. So when I use computer vision to detect an image, it describes perfectly that this is a flowers. Then I go into cars, and then obviously I upload a picture of this. It's clearly a car, so we'll describe the car. It even recognize the brand, so I would say that this is a Volkswagen, for example. This one is whatever it is, and Porsche, and so on. So it definitely recognize and describe the image in detail. But the moment I put something like this, where are these? Here. This one here is opening. Now, I'm going to ask you this question. What do you say is this? Would you say is a car or is a flower bed? How do you define it, right? And this is a bit of an artistic combination, but I found a gap in the computer vision service. So engineers at Microsoft have done an unbelievable job, and I'm very grateful to them for classifying hundreds of thousands of cars and millions of flowers around the world. So the algorithm, the service is able to recognize all the flowers that I tried and all the cars that I tried. As soon as I upload any of this picture, they fail miserably. They fail miserably. And they don't know. The algorithm doesn't know. The algorithm doesn't know. It's not able to recognize, and I get a very low score, like 55, 60% of accuracy, of likelihood that this is either flower or car. I mean, even if you ask a person, yeah, it's a car, but it's a car, it's a vehicle, it's a van, it's a tractor. There are a lot of flowers for sure. How you define it? Try to give it a name. So it's very hard, right? You would agree with me. So now, in doing this, we need to work out a different way of doing computer vision. I'm saying computer vision because it's a visual examples, but this applies to any context where there is this ambiguity. Now, the good thing is, at least for Azure, is that there is a service that does that, which is called custom vision. So you see there is a computer vision and there is custom vision. Now, computer vision is, as said, based on these pre-built models, and you cannot change the models, you cannot change the algorithm. So whatever you're going to use, whatever image, in this case image, use for this computer vision, if Microsoft, the Microsoft engineers have not trained their model with that type of image, it will not be able to recognize. So the moment you need to go into something more specialized, you need to go for something that is at computer custom vision. Now, this is custom vision and exists, and it allows to do two things that are very, very important. So the moment I create a new custom vision service, let's say that I'm going to create a new one. I already have one example, but I just want to show you this very quickly. The moment you create, there is you have a choice, and this is a choice that you didn't have before when creating computer vision or speech service or language service or translation service. You have here an option to choose: are you creating a service for prediction or training, or both? But let's say for prediction or training, and then the usual stuff, right? So assign a subscription, assign a resource group, a region, give it a name, and these sort of things. But here is the unique property of this custom vision. Are you creating a service for prediction or for training? What's the difference? Well, training is what we do here, right? What is it? Oh, come back. One second. Did I close it? Yes, I did. Okay. Here we go. This is where we do the training. So we are collecting a lot of images, and we are giving as a feed to the algorithm to learn from that categorized, tagged images. So the algorithm can learn from these models. Okay, back here. Prediction instead is the API that I consume from my front end, from my application. So is when I do the actual verification. And again, this is now creating a little bit of ambiguity in some way. Okay, let's create both. But when I create both, I'm actually obtaining two separate endpoints, two separate services, which I already created. So I'm not going to create another one, but I can show you the one that was already created before. I have one that is called, here we go, custom vision.training, another one custom vision.prediction. They are very similar. They are both custom vision. If I open the training one, I still have access to keys and endpoint, and I have my keys, location, and my endpoint. If I go into the other one, which is the prediction one, then I have exactly the same with keys, location, and endpoint. The endpoint obviously is slightly different because the URL reflects the name of the service itself, and the keys are obviously different. So why we have two different services? Well, to separate between the training and the model. This is an essential component that we didn't have before. With the predefined services, the AI services, we can only do the prediction, we cannot influence the training. And now coming back to this point, to the model, to the deployment, these two are, let me see if I can get with some pen here. These two aspects, 1 and 2, are two different things, completely separate, and they have to be, because training a model requires processing, let's say, millions of data points, images, in the case of custom vision or computer vision. So that requires an incredible power of computing to train the model. And this is something that you don't do in real time. So it's not that every time that you send an image for analysis, the model is trained on the spot. It would be impossible, right? So to do that, you need to do the analysis. The algorithm, the AI service works on pre-trained models. So this is incredibly time-consuming from a computing perspective. It requires big hardware, very likely GPUs to elaborate your to train your model in a more efficient way. Consuming it, so the prediction part of it, is less computing as expensive and is typically faster. So also from an infrastructure perspective, you probably don't need to deploy big hardware behind. Here, probably you need a big cluster of containers with a lot of capabilities and GPUs and so on. Here, you need something leaner, something smaller. And that is an efficiency also from an infrastructure perspective, cost perspective. This problem was still in Azure, also when looking at Machine Learning Studio. Has anybody used this Microsoft Machine Learning Studio? This service is going to be sunset soon, I believe by summertime this year. And this is still available because you can still use it at this URL here, which I'm going to put in the chat if someone hasn't seen it yet. We're going to put it here. Sorry, there was a question I haven't seen before from Kevin. Yes. Custom vision is like fine-tuning a pre-trained model. Okay, I probably didn't clarify this, so thanks for the question. Is not, that's the thing. Custom vision is using the same algorithm of computer vision, so you don't have to write the code for the algorithm itself, but you have to train the model. So you have to upload all the images that you want your model to be. So you're not going to write any Python code for the machine learning algorithm itself, but you do have to upload all the images and tag them. So you have to say whatever image is of this A, B, C, D label. So custom vision is not going to be able to work without uploading images and train the model. There is no pre-trained model at all. There is an algorithm which, so you don't have to do any coding, but you do have to upload it. It's going a little bit off topic because obviously, I would love to talk about custom vision and I can talk about custom vision for hours and hours. I use this service a lot, but this is the port. Oh gosh, team. Yeah, here we go. Customvision.ai. You sign in with your Azure account, and then you have the possibility to upload all your images and train the model with the images. You have to upload your images, otherwise it wouldn't work. And this is the experiment that I've done. I do it a lot of time because it's so much fun. I upload at least 5 images of cars, at least 5 images of flowers, so then the algorithm is able to detect the car and flowers, and then 5 images of this floral vehicle, which is not a car, it's not a flowers. I can call it any way I want. I have to come up with some funny name to define it. For now, I'm just call it floral car. You see, just floral car, but it should be something else. And then there are also some negatives. You probably have seen a few dresses here. You have seen Brad Pitt. These are meant to confuse the model. I do it on purpose. They're called negative. The negative is what it should not be. Okay. Now, if I upload here an image of an apple, this service will not be able to recognize the apple because it's not been trained to recognize apples. But computer vision, the one with the pre-trained model, is. And computer vision can do it on thousand different objects. Custom vision, you have to train the model with at least 5 images, otherwise it will not be able to recognize your object. But I said, you don't have to write the algorithm. The algorithm is the same as computer vision. Okay, close parenthesis on that. Let me show you this again very quickly, because I'm still trying to demonstrate where the problem is, right? So with the AI service, the problem is we work on pre-trained model and they are all deployed, so we only consume the prediction part of it. When we go down to machine learning, the old service, this machine learning studio, which I said, don't use it because it's going to go away in a few months. You can write here an experiment, which is a project, which is an algorithm that is all built visually. And again, I can talk about this machine learning for hours, but maybe another time, right? But basically, you start with data, you upload your data set, and this data set contains age, work class, education, occupation, marital status, relationship, race. So all these attributes that are used to do some income prediction. Very bad. I hate it. It is what it is. A lot of banks actually use something similar to grant a loan or not based on a lot of parameters. And you can't believe the biases that are there into these models. But that's another story. Then you split the data between what you go for training, for scoring. Then you use a specific machine learning algorithm that you can pick from here to initialize the model. It's a classification problem, it's a clustering problem, it's a regression problem. Obviously, you need to have some foundation of machine learning, data science to understand which algorithm to use. But then you train the model. Potentially, you can add also some Python script or R, which is the language of the data scientist. You know that, right? So then you can add a custom script for that. And at the end, you produce an output, which is published as a web service. I'm going to show you the web service because I've already published, but basically, you just click a button and Machine Learning Studio can publish all the magic that you have done there semi-visually. Power Platform, Power Automate, that you can build this workflow visually. Similar concept. So you build a machine learning algorithm with low code, mostly visual with those components in there, but you can also add some scripts, similar to Power Automate or Power Apps. You build everything visually, and then potentially you can add some JavaScript in there if you really want to. At the end, you click a button and you publish this as a REST API. And the beauty of this is that it all goes into Azure, right? So it's all hosted into Azure. Automatically, some containers, some Kubernetes containers are spin-off and allocated to host this URL at these endpoints that I'm going to show you in a moment. So it's opening up. And here we go. This is my REST endpoint. Is only a post with this unique URL, which is unique to this service. It accepts an input to this JSON payload with all the different attributes and produce in output a response, again in JSON format, with a score, label, and probability. Label is the name of whatever this algorithm is doing. This is an income prediction. So based on all these parameters, it's going to give you a probability. Is a regression algorithm, so it's going to give you an estimate of how much money you're going to make, right? So based on historical data, obviously, but it's based on label and probability in output. Now, without going into the detail of the algorithm, what I meant to say is that this is published in here. I can create any application, C#, Java, JavaScript to call this endpoint and passing this key in the HTTP header for authentication. I can test it directly here. So there is a little UI for writing all these things and just verifying things. I can even do Excel. So even Excel as I don't know if it's working. Is downloading? Yes, it is downloading. I can even use Excel, and Excel is a plugin that connects automatically to this very web service that I published. So it's all bundle this inside Excel. Is opening on my other screen. So as soon as it's done, I'm going to show you. Here we go. So Excel now is all pre-configured, enable it with this web service inside the spreadsheet, and it is able to call it. You see there is Azure Machine Learning plugin inside Excel, so I can put some sample data and do my prediction inside Excel. I mean, how cool is this? Now, what is the big challenge with this is, again, I have one infrastructure completely PaaS. It's not even PaaS. This is serverless, where I have zero control on the infrastructure itself. So I don't know what is being deployed. I don't know anything about it. And I don't have control on the performance, on the cost, and anything else. Now, it's fantastic if I'm a developer and I don't care about managing the infrastructure. But in the spirit of DevOps, this is a gap, because I don't know what is behind this. In light of this, Microsoft has evolved this machine learning studio, is retiring this classic version, and is moving into this new one. Yay! A new URL, which I'm gonna type here in the chat as well for you guys, ml.azure.com. And this is the new environment. Now, the new environment has the designer, which is exactly the same experience that we have seen before, and also has all the pipelines. Now we're talking about it. Now we're talking about DevOps for machine learning. So I can generate all the pipelines exactly the same way you will do it in GitHub Actions or Azure DevOps. They all YAML pipelines. But more important than the thing that I really like is the possibility to control the environments. So you can create environments. There are some that are predefined, called curated environments, because they are specialized for specific workloads. And obviously, you can create custom environments. As you can see, environments are based on Ubuntu. They are specialized for training. Some are based for prediction. They have a Python engine. They have some should have a R engine. Some have GPUs, etc. So then you choose the environment that you prefer to use. And these environments are optimized for the specific task they have to accomplish, which is training the model. And obviously, training varies a lot depending on the strategy that you choose. Classification is all about identifying the different classes of object. This is an apple, this is a banana, this is an orange, different class. Or a regression, which is an estimation of a quantity, income, what was the name? Income prediction. Income prediction is gonna estimate how much you're gonna make based on all the parameters that are put in place. So this is a regression. Anomaly detection, clustering, which is another type of classification, but for unlabeled data. So every type of these algorithm in some way, or these types of machine learnings requires different training capabilities. So then you use an environment that is specialized for this capability, and you have full control on the infrastructure and full control on the cost of this infrastructure as well. And then you go into the endpoints, right? So the endpoints, the models and the endpoints. So you also control the storage. Really? No, thank you. Yes, 10. Go for it. Then you have control on the models. So obviously you store the model in your Azure storage account. So you have a full control on where your models are, which you don't have here. You don't have here, because where are you storing the models here? Well, you don't, right? Because these are not your models. Even with custom vision, you upload the images and they are in this region where the service is published, but they're not in your Azure subscription. So that customvision.ai service that I briefly showed before with the images of Brad Pitt and the cars and the flowers, I don't have control on the storage of it. So obviously, until you are uploading flowers, whatever, right? But when you start uploading more sensitive information, well, yeah, I sort of want to have control on it. You know what I mean? And here the same for the classic machine learning studio. I have no control on the storage. I have no control on the endpoint. Here I do. So then I can attach, I can store my model into a storage account that I own, is in my Azure subscription, and I can publish the endpoint on my AKS, Azure Kubernetes Service, that I own, I control, I deploy it. Now, as you can understand, this is introducing a little bit of challenges for those who are not used to work with infrastructure, but it offers a lot of other opportunities because you have full control of the infrastructure itself now. And just to go a little bit quicker on a couple of slides that I have just to finish off this conversation. Remove this. There we go. All right. Now, the traditional siloed approach that we used to have is down here, the data scientists, they work with whatever platform they are, Jupyter notebooks, whatever they use to produce their data and they train the model, and then they publish the model, and we have these expressions. They throw the model over the wall, and the wall is the other department, which is the traditional application development, where they get the endpoint, they get the key, and they start using it. So whatever they're using on a predefined Azure AI model or a custom vision, again, we may be able to do another session about custom vision. You will love it because it's really interactive. You can do a lot of things yourself as well. But custom vision at the end produce an endpoint that you can consume with your trained model, which is amazing because you can really train the model, see how the training process works. But then the app developer will start using that model that they've been thrown over the wall completely blindly, without understanding what is the infrastructure behind, and what if there is something at validation point that doesn't work. Is the problem in the application, in the algorithm, in the data? How do we improve it? That's completely missing. It has to go back to the data scientist, tell them something doesn't work, identify the problem, and try to get that sorted at whatever level the problem is. Who knows? It lacks complete integration. The solution is this complicated diagram. I mean, I'm going to share the slide with you guys, so you don't need to capture everything here. Let's go into the essence of it. But the essence of this slide, which is complex, I totally get it, probably is not the best slide for a live demonstration, but it's more from a solutioning this, but it's basically in here in customizing the model, deploying the model, and more important, retrain the model after collecting feedback. This is completely missing in the siloed approach. Here we are working together on an essential component of the solution, which is the model store, where basically is what the new machine learning studio offers to store all these models. So you can store it, you control it, the storage, and then you decide, okay, model version 1, model version 2, model version 2.1, because I've done some minor revisions. And then you expose these, you customize, you expose the model with a specific version to the app developer. They go through the normal application stuff. They do React, they do some backend, they publish the traditional DevOps pipeline, whatever that is. Then at some point you go into testing and you realize, oh, something is not quite right, we need to fix it. Collect that feedback and retrain the model completely automatic based on the feedback that is received. This process of retraining will improve the model and will upgrade the model 2.1, 2.2, 2.3, whatever the strategy is. The model store will keep all the versions, so you can obviously roll back to whatever previous version, and then again go publish these into the latest endpoint, exactly how you would branch your code in GitHub into a repo. The same works for models, and this is the missing connection point between the traditional source code approach with GitHub repositories, branches, and pipelines for publishing the code, and models. We have seen all the AI services completely with a pre-built model, like a black box. We just trust that things work. And the old machine learning studio, the classic machine learning studio, which you can create, where you can create your machine learning experiment, but have no control on the automation and of the service itself and the storage of of data. And the new approach, which is based on having more control on all the phases of the software development lifecycle. There is one last thing I want to show you before opening this scan, before opening to a few questions, which unfortunately is it's not unfortunately, it's just in another slide deck. There you go. I didn't have the time to merge it. I'll do before sharing, which is the life cycle of the model, right? So inside the larger software development life cycle, which includes all the different stages of development of the application, you have to sort of consider there is a life cycle of the model inside the larger software development life cycle. And a model has a life of its own because it goes through the different stages, which now we know we can control and are part of this new way of doing DevOps. So the MLOps now includes also the aspect of training the model, packaging and publishing, validating the model before actually deploying it, and monitoring. We do monitor our applications. We do logging. We do app insights, Grafana, whatever we use for logging and monitoring our applications. The same happens with the infrastructure. We have all the agents that keeps under control CPU utilization, memory allocation, storage on database, file system, whatever that is. We have to do the same also for our models. Our models are not static components. They need the constant retraining to produce more accurate result. The score can improve also because we improve the quality of the model over time. This is not a real-time process. It's a process that is completely batch. It happens with a frequency that depends on business requirements that you consider valuable. Some people do it some organizations do it every 24 hours, some every 24 days, right? It depends how frequent you get feedback and new data, and to catch false positive, false negative, everything that requires improvement of the model. Very likely you have a higher frequency of retraining at the beginning of the application life cycle because your model is still building up, you're still collecting data, so you don't have a lot of information, a lot of data points, I should say. Over time, when your model matures and is richer, then you probably don't need to retrain that frequently. The last slide, the promise that I want to share with you is around the 6 principles of responsible AI. One thing that is very, very important with this new approach where everything is unified is that you now have control on the different aspect of responsible AI, especially on the fairness. Fairness is an indication of the algorithm is not gonna treat people differently based on attributes, condition, properties, and we don't know a pre-built model how it's been trained. We just accept that is right, and is right according to the engineers that have trained the model. So what happens basically is that biases always exist in models because it's just part of the way things are built by people, by humans. I'm pretty sure that Microsoft is doing their best to reduce the biases in their trained models, and so the predefined AI services can filter already on biases that can be introduced in machine learning, but you never know, and it's always driven by a Western culture with data engineers, data scientists that are based in Seattle, in Redmond, wherever they are, wherever the culture is. So if you want to have more control on this, the approach where you have your models trained and retrained with your input, with your algorithm, can ensure that you can minimize introducing biases in your algorithm. But that again is a conversation for another time, because there are a lot of different strategies for reducing or mitigating risk of introducing biases in your algorithm and in your data as well. So look, this was overall the thing that I wanted to share with you. I give you one last data point or one last piece of information. So you can also have a look into this. Actually, rather than showing, I put this into the chat. It is a website. If there are any questions, that's a good time. 1 second that I get to this one here. Here we go. There are 2 websites that Microsoft has done, which are on GitHub. Let me see. Where am I? I'm still sharing, and I'm not sharing anymore. 1 second. I'll put it here. Here we go. These 2. Oh, Teams, what happened to you? Getting very slowly, yeah? Okay. And look, I appreciate there is a lot of information, and there are a lot of big font. I don't get this chat. I mean, this is me talking. Oh, okay, we are recording, so I'm not saying. I'll say later after the recording. I don't get this chat. Anyway, question. We need to also be adding a monitor prediction output and data input to detect context shift and functionality decay. I think this is a good point, right? So everything that you normally do in your traditional web or desktop or mobile application, now you can do it also in machine learning and controlling the deployment of your models. So monitoring, absolutely, yes. You keep on monitoring your models and you retrain your models based on the feedback that you get. So these 2 links here that I just showing here in the chat also, they are your starting point. There is a lot of information in there, and the second one is specialized for Python. The first one is a bit more generic and more architecture oriented. The one with Python is more hands-on with some code snippets in Python language, obviously. Alrighty, I guess we are at the end of the session, and probably I took even a few more minutes, but thank a lot for your attention, and enjoy your machine learning experiments in the future.
Thank you very much, Stefano. I'm not gonna lie, you kind of excited me a small bit with the thoughts of getting into that sort of stuff. So I'll see if I can play around with sometime this weekend, what can come out of it. But that's brilliant. Thank you so much.
Thanks a lot, everybody.
Okay, I'm going to stop the recording now, and we shall have it up on YouTube pretty soon. Thank you so much.